Continuing our discussion on functions and relations, remember a function in a function, a single input gives back exactly one output. In a relation, a single input gives back one or more outputs. So to summarize that and put it all together, a function is a relation that gives back exactly one output for each input. And we did discuss that last time. So looking at what we call mappings, okay? Mapping diagrams are those circles that you see with numbers on each side that have arrows going from one to the other. So mappings show how a function or relations assigns input values to output values. So it maps them together by drawing those arrows. The left side shows all possible inputs. The right side shows all possible outputs. And the arrows connect the inputs to their outputs. It says, how can you tell when a mapping diagram shows a relation that is not a function? Well, in order for something to not be a function, what that means is that there's more than one output for the input. So I'm going to draw a picture because it's almost easier to see in a picture. If I had a mapping that had the numbers 1, 2, and 3, and over here it had 4, 5, and 6, well, if it's not a function, then what's going to happen is one of these numbers, for example, the number 1, is going to have more than one arrow coming from it. So right here you see there are 2 arrows stemming from the number 1. That makes it not a function. So how can you tell when a mapping diagram shows a relation that's not a function? There is more than one arrow. Starting at a given number, some number. So if it is a function, then that means there is only one arrow coming from each number. That's how you know it is a function. So an example of something that's a function, if I had the numbers 1, 2, and 3, and again 4, 5, and 6, well, if I had just one arrow that went from one number to the other, that would make it a function. So how many ordered pairs can be written for each arrow? There's 1. So each mapping represents an ordered pair. So for this one, you want to draw a relation that is a function. So if it is a function, then this side there should only be one arrow from each number. Now, in a mapping, you do not have to use all of your arrows or all of your numbers, and that's really important. And you can have more than one arrow going to a number. You just can't have more than one arrow coming from a number. So, for example, this would be a function, what I have drawn here. It's okay that I didn't use the 2. That is perfectly fine. So if I were to list out the ordered pairs for this function that I have, well, my first ordered pair is 1, 1 because that's the first arrow that I have. My next ordered pair is 2, 1. The next one is 3, 3. And the last one is 4, 4. And again, we can tell this is a function because if you look at all of your x's, all of the first numbers, they only show up once. There's just 1, 1, 1, 2, 1, 3, and 1, 4. So you want to show something that's not a function. Not a function, that means you want more than one arrow coming from something on the left. So it could look something like this. And this would not be a function because this right here. Because there's the 2 arrows. It could even be 3 arrows, it doesn't matter. makes it not a function. It doesn't matter if the numbers on the right are used more than once. In this particular example, 3 was used more than once on the right side. And in our previous problem, the number 1 was used more than once on the right side on the y side, and again, that did not matter. So if I were to list out the ordered pairs, I would have the ordered pairs 1, 1, 2, 3, 3, 2, 3, 4, and 4, 3. And again, this one is not a function because the x value 3 is utilized more than once. When I put in 3, I can get out 2 or 4. Talking about a graph shows a function or relation plotted as ordered pairs, and those ordered pairs are always in the form of x and then y. The x-axis shows the independence, and the y-axis shows the dependence. And as long as all the ordered pairs have different x values, the graph shows a function. And that we could also say the graph of a function never has two different points with the same x coordinate. There's a test that we can use to determine whether or not a graph is a function, and that test is called the vertical line test. And the vertical line test says that if you can draw a vertical line, if you can draw a vertical line and it only touches the graph once, that makes it a function. If it touches more than once, that makes it not a function. On the next page, we're going to look at a few problems that are examples of functions and not functions from graphs. So this first one, it's an oval. Well, if I draw a vertical line, this one, for example, when I draw it, I touch the graph twice, so that makes this not a function. If I move to the right, this particular graph is called a hyperbola. Okay, I'm going to label these because you're going to need to know these. This is called an ellipse. This is called a hyperbola. If I draw a vertical line, I'm going to touch the graph twice. So again, this is not a function. This particular graph is called a cubic. And no matter where I draw a vertical line, that vertical line only touches the graph at one point, no matter what. So this one is a function. The last one is called a parabola. And if I draw a vertical line, again, every time I draw it, it only touches it once, so it is a function. And remember that because these are all graphs, all of these are relations. I want to show you one more example of something that is not a function. So here's my x-axis and my y-axis. If I had a graph that looked like this, because this part right here, when I draw that vertical line, it touches it more than once, it's not a function. It doesn't matter that this is 1, this only touches 1, because this one touches more than 1, that makes it not a function. Also, anything that has a vertical line in it, for example, this graph, because this is a vertical line, and when I do my vertical line test, I'm touching the graph here, and here, and here, and here, and here, and every other place in between, that's also not a function. Looking at a few examples. So it says for questions 1 through 3, refer to the mapping diagram for the age parentheses student. So remember, the student is the input, and this goes back to what we talked about in the last lesson. And the age is the output. And everything on the left is always your inputs. On the right is always your outputs. So when they're asking you age Peter, what they're wanting to know is if you put Peter in, what age do you get out? Well, you get out the age of 16 because that's the arrow that goes from Peter to the other side. Number 3 says, what's the age, parentheses, Angela? We would read that age of Angela, by the way, and we would look what the arrow is going from Angela to the other side, and it is 18, so that's how old she is. For questions 4 through 10, we're supposed to determine whether or not these representations are functions. So remember, from a mapping, we have to look at the left side. So we're going to do number 5. And what I'm looking for is if there's more than one arrow coming from a number. So I'm not even worried about this side. When I'm determining if it's a function, this side does not matter. Okay? I can mark it out all I want to. It doesn't matter. All I'm looking at is the right side, and I'm looking at 0. It only has one arrow. 1 has one arrow, 2 has one arrow, 3 has 2 arrows. So that right there, the 2 arrows makes it not a function. Moving on to number 7, I have this curve here. It's a graph now. So I'm going to use, for any graph, I always use what we call the vertical line test. I'm going to abbreviate that VLT for vertical line test. So I'm seeing if I draw vertical lines, how many times does it touch it? Well, every vertical line hits the graph one time, so that makes this a function. Number 9, again, vertical line test. If I draw a line here, oops, twice, so that makes it not a function.